Physical disorder. PM2.5 prevention technology and design space. The problem of PM2.5 particulate matter pollution is a global issue that has impact on the economy, society, the environment, and human well-being. Thailand is one of the countries that has been facing the problem of PM2.5 pollution for many years. The sources of PM2.5 particles include toxic emissions from industrial factories, traffic emissions, and biomass burning. The average PM2.5 concentration should not exceed 50 micrograms per cubic meter over a 24-hour period. When the PM2.5 levels exceed the standard, it has adverse effects on human health and quality of life. Therefore, this study aims to investigate the factors that contribute to the occurrence and reduction of PM2.5 particulate matter pollution. The findings can be used to design and develop strategies to mitigate PM2.5 pollution in various areas, both within the country and in other affected regions. The implementation of these strategies can help alleviate and address the aforementioned issues, as well as provide spaces that promote outdoor activities and stress relief. PM2.5 particulate matter refers to airborne particles that have a diameter smaller than 2.5 micrometers, or about 1/25th the average width of a human hair. These fine particles are small enough to be inhaled into the body through the nose and can penetrate deep into the respiratory system. And it is particulate matter that is generated from human activities such as exhaust fumes from vehicles, forest burning, waste incineration, as well as the accumulation of gases and other pollutants in the atmosphere, particularly sulfur dioxide and nitrogen oxides. And it leads to health impacts when exposed to the particles, such as nasal congestion, watery eyes, sore throat, aggravated allergies, skin disorders, inflamed lungs, respiratory tract infections, cardiovascular diseases, and pulmonary conditions like emphysema. And the Lad Krabang area itself is another significant area that is heavily affected by the problem of PM2.5 particulate matter. Due to the issues arising from this problem, a study has been conducted to find ways to design an environment to address the problem. Undergraduate and graduate students from the School of Architecture, Arts, and Design at King Mongkut's Institute of Technology Lad Krabang were selected for this study as they are a group directly impacted by the issue. Through interviews with the participants, it was found that the students do not yet fully comprehend the importance of the direct health impacts of PM2.5. They also perceive that there is currently no immediate necessity for accessing PM2.5 free spaces. However, they expressed a desire for the creation of spaces that promote physical activities. Currently, engaging in physical activities in open spaces is hindered by the challenges and obstacles posed by PM2.5 particulate matter pollution. Through studying and reviewing literature and relevant articles, the issue of PM2.5 pollution that occurs in Lad Krabang area has been identified. Vehicles particularly play a significant role in contributing to the problem of particulate matter pollution in Lad Krabang. Based on this understanding, various relevant components such as the architectural form, titanium dioxide, the process of photosynthesis, and electric charge were utilized in the design process to address and mitigate the particulate matter pollution in the area while promoting physical activities. The conceptual design utilized the distinctive characteristics of bees, which are insects capable of measuring the quality of air and the natural environment, as well as assessing the air quality. Bee colonies, when flapping their wings simultaneously, can generate electrical charges. Additionally, the form of beehives, which possesses unique and iconic features, was incorporated into the design. In addition to that, the concept of green belt has been employed to restrict the expansion of the metropolis. For example, London has had green belt legislation since 1938, specifically designating the areas along Tailing Chan and Minburi adjacent to Lad Krabang as conservation and agricultural zones, represented by green shading in the urban plan. This is a collaborative effort in the design process. Furthermore, the concept of using bicycles for exercise incorporates the idea of generating clean air through solar-powered air purification. By utilizing sunlight to charge lithium-ion batteries and employing filters powered by solar energy, the bicycles can filter out particulate matter from the air, allowing riders to breathe clean air while engaging in physical activity and other activities. Another important design concept is the utilization of the flow design program to simulate the airflow through the architecture designed in front of shopping mall entrances. Through this program, it is discovered that the airflow passing through curved half-arch columns can create wind speed and direction that are suitable for effectively capturing PM2.5 particles. Furthermore, the use of titanium dioxide, TiO2, is employed as a photocatalytic substance in colors and construction materials to eliminate pollutants from the air. This process, known as photocatalysis, is a natural chemical reaction that occurs when light interacts with oxygen and moisture. The activated oxygen is produced, resulting in a water-loving and water-friendly surface. Negative ions, or anions, floating in the air and attracting particles through static electricity can indeed capture other particles in the air, such as PM2.5 dust. This causes the dust particles to become heavier and fall to the ground, resulting in a reduction of PM2.5 levels in the air. We can then remove the PM2.5 dust on surfaces by sweeping or vacuuming and by cleaning/washing. The most important element used in design for filtering and absorbing particulate matter is microalgae air purifying algae. It is a type of algae that can actively capture and sequester carbon dioxide in real time. The algae contained within it functions to capture and store carbon dioxide molecules. Then, through photosynthesis, it synthesizes pure oxygen and releases it back into the air. As for the care and maintenance of microalgae, some simple methods include: 1. Air compression. Provide fresh air circulation around the microalgae culture to ensure an adequate supply of carbon dioxide for photosynthesis. 2. Water changes. Regularly change the water in the microalgae culture to maintain its cleanliness and provide necessary nutrients. 3. Microalgae replacement/refilling. Periodically replace or refill the microalgae culture with fresh and healthy algae to ensure optimal growth and filtration efficiency. And 4. Cleaning the air filter. Clean the air filter regularly to remove any accumulated debris or particles, ensuring proper airflow and efficient filtration. In addition to that, the remaining microalgae can also be utilized for 1. Animal feed. Microalgae can serve as a nutritious feed source for various animals, such as fish, shrimp, and livestock, due to their high protein and nutrient content. 2. Biofuel. Microalgae can be used as a source of biomass for the production of biofuels, such as biodiesel, through processes like extraction and transesterification. And 3. Biofertilizer. The biomass or byproducts of microalgae can be processed into biofertilizers, which provide essential nutrients for plant growth and improve soil fertility. By selecting the area near the cafeteria as the sports field, it becomes easily accessible and appropriately sized for various activities. Furthermore, the air circulation in this area is suitable. The designers have proportioned the usage and participation in recreational and exercise activities appropriately, divided into various areas as follows: 1. Boxing area, 2. Recreational activity area, and 3. Fitness area. Furthermore, all activities can be integrated with air purification and renewable electricity generation systems. The structures are designed to respond to air purification using rotational energy from exercise. The entire structure is coated with titanium dioxide and releases ion charges to capture dust particles. It also incorporates a water spray system to clean the dust during nighttime. The green honeycomb-like structures contain microalgae panels that are capable of absorbing pollutants up to 50 times more effectively than trees. UV lights within the structures turn purple when the level of particulate matter exceeds the standard, indicating air quality issues. The flooring, when walked upon or jumped on, generates electricity through the kinetic energy of movement to facilitate the air purification process. Additionally, some parts of the flooring are covered with grass to minimize dust dispersal. Furthermore, there are stationary bicycles for air purification, equipped with LED screens that display scores based on cycling performance and other activities. This design allows for both exercise and air purification to be integrated effectively. Beekeeper 2.5. Fresh air, fresh start.